The night the moon disappears, you probably wouldn't notice. The sky dims by a fraction of a lux, nothing more. But beneath your feet, 2.5 terawatts of tidal energy simply stop. Within 24 hours, global tides collapse by more than 80%. And that is only the first day of a chain reaction most of the world won't see coming until it's already too late. In a single second, the rural night sky plunges from a silver-lit baseline of 0.3 of a lux down to the absolute dark of deep space, where starlight provides a mere 1/10,000th of a lux. In major cities, artificial light pollution masks the void, but at the Jet Propulsion Laboratory, computers register the celestial catastrophe within 3 seconds. The laser pulses routinely fired at the Apollo retroreflectors on the lunar surface vanish into empty space, never returning. Gravitationally, the Earth-Moon barycenter instantly collapses thousands of kilometers inward, settling at the planet's precise center of mass. Yet the physical world still appears completely undisturbed. Earth's elastic crust and ocean basins take hours to respond to this sudden release of gravitational tension, creating an eerie, deceptive window of quiet before the true planetary restructuring begins. The global ocean, once bound to a relentless rhythmic pulse, instantly loses its primary driver. The principal lunar semi-diurnal tide, known to oceanographers as the M2 constituent, vanishes. This represents a sudden catastrophic extraction of 2.5 terawatts of mechanical power from the marine system, nearly 2/3 of Earth's total tidal energy. The oceans do not simply freeze in place. Instead, they collapse toward the far weaker solar tide, which operates on a mere 0.5 terawatt of power. Within 24 hours, the global tidal amplitude plunges by more than 80%. Across every coastline, tide gauges record a dramatic, unprecedented flattening of the water's rise and fall. High tides fail to reach their expected marks, and low tides cease to retreat to their historical limits. The daily high and low water marks begin to drift in timing, realigning solely to the sun. The global oceanic engine, stripped of its main gear, has slowed to a whisper, initiating a silent crisis across the open seas. Deep below the surface, the true crisis unfolds within the ocean's dark interior. The sea is a vast, living circulatory system kept in motion by constant violent stirring. Lunar energy forces immense volumes of water over jagged undersea ridges, driving the deep vertical mixing that prevents global stagnation. Without this relentless lunar churning, the ocean's distinct layers begin to separate. Argo profiling floats drifting in the abyss would record an immediate plunge in vertical velocity, signaling a rapid decay of internal waves. This loss of physical agitation halts the upward transport of deep, nutrient-dense waters, leaving the sunlit surface starved of life-giving elements. Long before atmospheric climate shifts materialize, satellite altimeters like Jason 3 trace this quiet, mechanical failure of the marine engine. The circulation has stalled, and the consequences will soon break violently where these quiet waters meet the shore. The boundary where the sea meets the land begins to decay first. Across Earth's coastlines, the intertidal zones, the planet's coastal lungs, are freezing in place. In estuaries and mangrove forests, the vital, rhythmic rise and fall of water simply stops. Without the daily flushing of the lunar tide, these highly productive habitats lose their natural circulation. Consider the Bay of Fundy, where massive 10 to 13-meter tides once forced millions of tons of water through coastal channels twice a day. Now stripped of lunar pull, the water barely moves. In the Sundarbans, the world's largest mangrove forest, the tidal prism shrinks by 2/3. Salt water no longer pushes inland to mix with fresh river basins, causing soil salinity to spike and choking the root systems of the keystone Sundari trees. Nutrient transport stalls. Runoff from agricultural fields and rivers accumulates on the shores instead of being swept out to sea. This organic buildup feeds massive bacterial blooms, starving the water of oxygen. Coastal environments rapidly transform from vibrant nurseries into stagnant, anoxic dead zones, mirroring the suffocating, stratified depths of the landlocked Black Sea. The coastlines can no longer breathe. The planetary engine does not fail all at once. Instead, the quiet stagnation of the oceans begins to alter the air above them. Without tidal currents to churn the seas, coastal waters absorb solar radiation differently, causing sea surface temperatures to warp. This disrupted thermal balance ripples into the atmosphere. Computer models suggest that within weeks, the delicate exchange of heat and moisture between sea and sky begins to fracture. Regional weather patterns drift. In the tropical Atlantic, cooled coastal upwelling zones may alter the paths of seasonal storms, shifting their landfalls. Across the Indian Ocean, the vital monsoons, historically tuned to marine temperature gradients, could delay their onset by up to 10 days, disrupting rainfall cycles that sustain billions. These cumulative atmospheric shifts are not a single global storm, but a slow, regional unraveling of the seasons we once trusted. Away from the artificial glow of cities, the night sky is now permanently black. The soft, reflective wash of moonlight, which once averaged 0.3 of a lux, is gone. In its place is only starlight, a cold envelope of just 1/10,000th of a lux. This sudden darkness silences an ancient biological clock. Across the planet, countless species rely on these light cycles to navigate and reproduce. Along the beaches of Florida, newly hatched loggerhead sea turtles emerge into a world without their primary compass. Normally, they crawl toward the bright horizon, reflecting off the sea. Now, with the ocean as dark as the dunes, they scatter inland, marching toward starvation. In the Pacific, the Grunion tide fails. These fish, which for generations timed their mass spawning to the peak lunar tides, find no environmental cues to beach themselves. Off the coast, reef-building corals remain dormant, their coordinated release of millions of gametes forever frozen without the post-sunset dark window that once initiated new life. The moon behaves as a physical shield, wielding its mass as a gravitational buffer. For over 4 billion years, its gravity has deflected incoming space debris, intercepting nearly 20% of Earth-bound projectiles. Dynamical models from the Southwest Research Institute indicate that without this celestial defense, Earth's physical exposure to near-Earth objects rises. Over geological timescales, the terrestrial impact rate would double. This loss of shielding does not trigger an immediate, apocalyptic bombardment. Instead, it marks a permanent degradation of our defenses, leaving a vulnerable planet exposed to the random hazards of the deep solar system. The greatest destabilization is not atmospheric, but orbital. Currently, the moon's gravitational torque acts as a cosmic gyroscope, locking Earth's axial tilt within a stable band of 22.1 to 24.5 degrees. This steady obliquity regulates the predictable cycle of our seasons. But without this lunar anchor, the planet's spin axis is projected to drift. Over millions of years, as modeled by astronomers Jacques Lascar and the team of Tuma and Wisdom, Earth enters a regime of chaotic precession. Computer simulations suggest the tilt could wander wildly, potentially reaching extremes beyond 45 degrees. At these angles, seasonal contrast would become severe, swinging the planet between intense equatorial heat waves and prolonged runaway ice ages. Decades into this moonless era, humanity confronts a quiet restructuring of global survival. The first fractures appear along the coastlines. Marine ecosystems, stripped of tidal energy, suffer immediate collapse. Ocean models project a 10% drop in global marine protein within 50 years. Low-lying ports and coastal economies absorb devastating shocks as old shipping lanes and fisheries vanish, while wealthy nations build massive seawalls and relocate populations. Artificial engineering cannot replace a lost planetary engine. For human civilization, the ultimate threat is not sudden extinction, but a slow, irreversible transition into a state of permanently managed decline. The moon is no mere ornament in our night sky. It is the silent anchor of terrestrial life. Every heartbeat of our planet relies on its distant gravitational grip. We exist only because it holds us steady. Subscribe to join our next journey into the cosmos.